Today we're talking about the centroid. It's the last lesson in the chapter. Okay, the centroid. Now listen, I'll collect them. Yes. Okay. Listen. Shh. So the other day, I had you guys when Tuesday. Tuesday we learned that altitudes went to orthocenters, angle bisectors went to incenters, and perpendicular bisectors went to circumcenters. Listen, you got to know that stuff. On the test, it's going to say, draw a circumcenter. You're going to need to know how to get there. Okay, you're going to need to know you need perpendicular bisectors. All right? Today we are covering medians. Stop, Sekou. Eli, give it back.
Hang on, I have a question.
Yes.
So, tell me just went over it, but I forgot it already. So, which point does the circumcenter make the circumscribed?
Yes, that's how they work. In-center makes inscribed. Okay, so that's a great way to remember it. Hey, if it's telling me to have a inscribed circle, okay, then I know I used an in-center to get it. If the circle is circumscribed, I used a circumcenter to get it. Listen, the circle decides it. So if it's an inscribed triangle, that means that the circle is circumscribed. So you use a circumcenter. The circle determines that. Yes, Sekou.
Okay, so you know the triangle and then the circle in it?
Yeah.
People like this.
Yeah.
Is that like an inscribed?
The circle's on the circle's on the outside of that. Circle's on the outside, and then the person standing there, and the triangle's inside. Yeah, I'm pretty sure. I could be wrong. We'll look at it after. Okay, so today we're covering this last one. All right. So we know that angle bisectors are concurrent, that altitudes are concurrent, and that perpendicular bisectors are concurrent. What about medians? Okay, what about medians? So we've got to figure out whether medians are concurrent or not. So first of all, what is a median? Let's review. What's a median?
A vertice to a midpoint.
Comes from a vertice, goes to the midpoint of the opposite line. So I've got to find the midpoint of the opposite line. So how do I find midpoints?
You go a little bit more than half of
Basically a perpendicular bisector. So I'm going to draw all my circles again.
Is a perpendicular bisector basically altitude?
What'd you say?
No.
You have to, technically you only have to find it for two of them.
What? Miss G. Miss G.
What?
Is perpendicular bisectors like basically altitudes but in the middle of the line?
No, not at all. They're not 90s.
They're not 90-degree angles?
Well, perpendicular bisectors, okay, an altitude is a perpendicular, but it's not a perpendicular bisector. Perpendicular bisector cuts a line in half.
Yeah.
An altitude, yeah, they're both right angles. One cuts a line in half. One comes from a vertex and forms a 90. That's the difference. All right, so yesterday I figured out that I have a ruler. It was a great day for me, It's been hard, but now that okay, I'm gonna erase it, Sekou. Okay, so I just have to find the median here. So I could draw my line there. Let's find the median of these two. Come this way. Huh? I have to find the medians. I need the midpoint, and I need the vertex in order to find if the medians are concurrent. Right. So I have just found my 3 midpoints. Now that I have my midpoints, I'm going to construct my medians. All right. So let's construct medians. I'm coming from vertex to the midpoint. From vertex to the midpoint. From vertex to the midpoint. Are they concurrent? Yes. Praise the Lord.
What is this called?
Why is that good?
That's called a moron.
It's the centroid.
That's the answer.
That's called a moron. Okay. Now we haven't done this yet. It's called the centroid.
I have a question.
Yes.
What are these things called? The lines from the midpoint to the vertex? What are they called again?
Midpoint to just the median.
Yeah, what was that called?
It's called median?
Those are medians.
Oh, what?
Morons. All right, so listen here, guys.
Central.
Guys, you're not going to have time to finish your worksheet. I'm just saying. All right. Median concurrency theorem is the three medians of a triangle are concurrent. Okay, so yes, the medians are concurrent. All right. The point of concurrency, the point where they meet, is called the centroid. So for angle bisectors, I have a what? An incenter. For perpendicular bisectors, I have a what? Circumcenter. All right. For altitudes, I have a what? Orthocenter. And for medians, I have a centroid. Yes. Centroid. All right. So let's. Shh. Okay. The incenter was equidistant from the sides. Okay. We already did an example of that today. The circumcenter was equidistant from the vertices. Is there anything special about this point? Now, we're going to go back and just look at it. Okay, so this right here is showing us three medians. They're all meeting at one point called the centroid. So, Davis, what can you tell me?
It's equidistant from the sides and from the vertices.
No.
It's equidistant from the median. The midpoint.
No. Okay, so listen. Shh. This right here, this guy right here, okay, is not the same as this guy. This one's clearly smaller. Okay,
those are all medians?
I'm not assuming. I'm not assuming. Look, okay, you want to measure it? Great. All right. There's zero assumption with that. Okay, so my drawing is drawn to scale. That's 4.5. And this is not even 4. Okay, so no, those are not the same. Listen, it's kind of hard. It's kind of hard to pick up what it is. All right, so our centroid theorem is the centroid of a triangle divides each median into two parts, so that the distance from the centroid. So in this situation, D is our centroid. From the centroid to the vertex. Here's the vertex. I'm just talking about this. Is twice as long from the centroid to the midpoint. So if
every time.
Shh, yep. Only with a median. Only with a median and a centroid. Okay? So if DE was X, if it was length X, what would RD be? 2X. 2X. All right? Hey, how about if I just know what the longer part is? What if that's Y?
That's half of Y.
Thank you. You redeemed yourself right there. Half of Y. All right, so if the big part, if I know the big part,
Why do we need that?
because it'll help us find distances. It'll help us find,
How do you know the distances?
because we want to know how long the triangle is, how long the median is. Okay, so we can find a lot of information from knowing this. So if I have the big part, just cut the big part in half, and it'll get the smaller part.
If you have the small half, double.
Double it, right?
The
I'm
next step,
guessing-
this was trigonometry.
This is not trigonometry.
What's trigonometry?
Trig?
Trig sucks.
Trig, you use angles. You use angles to find lengths, or you use length to find angle measures. We are not associating an angle measure and a side length at all. Okay, we'll do a little trig at the end. It's a lot different. Shh. Yeah. Okay, so stop with the bottle, please, Logan. All right, so if I have the smaller part, I know the longer part is 2 times that. If I have the longer part, I know that it is half of the smaller part. All right, so that's the centroid theorem, guys. Centroid theorem. All right, so from here,
Ugh.
Yes.
So tired.
So are we gonna like have to like make an equation and all this stuff and like solve it, or are we just gonna know that it's 2 x and half?
I mean, you'll like an example problem. An example problem would be if I said RD equals 8. RD equals 8. All right. And then what if I said ND equals RD plus 4? What is DO? Okay, so RD is 8. RD is 8.
Yeah.
ND is 8
So DO
plus
would be 6.
4.
So DO would be 6.
So DO would be half of that, half of
It'd be 4
12.
plus 2.
So 6. That's like an example problem.
Okay, but there's no like algebra.
If there was an X, if I told you that RD was 8x plus 2, and then you had to figure out what
So
double that would
you
be.
could say RD is 2 or 3x, so then you have to find.
But that you couldn't solve that without another number.
Yeah.
You'd need more information than this. Okay? All right. So, hey, is that making sense, guys?
Yes.
All right.
That's the first thing that's legitimately made sense.
All right. Another thing to know about the centroid is the centroid is the center of gravity for a triangular region. So, for any triangle, let's take my triangle here. If I cut this triangle out, all right, and if I put my centroid right here on, it would balance. It's the center of gravity. Yes. All right. It perfectly proportions.
Oh, so centroid is the middle of all medians.
It's not the middle.
Or it's the
In center would be technically the
or
middle.
concurrency of all medians, whatever.
Yes, exactly. The point of concurrency for all medians. What?
Currency. What does that mean again?
Concurrency means that they intersect at the same point. More than 2 lines intersect at the same point.
See, that's what I was trying to say.
Instead of moron.
Like there, triangle mid-segment theorem.
All right. All right. So, knowing that the centroid is the center of gravity is also important. You need to know that the centroid is the center of gravity. All right. So, we know the special stuff that has to do with the in-center. Okay, what's special about the in-center, guys?
The in-center
The
is
in-center
middle.
Inscribes a circle, but how come? Because it's what? It's equidistant from the sides. Thank you. What's special about the orthocenter?
It's in between all.
It's equidistant from the vertices.
Yes.
Okay?
Okay, I'm not gonna lie, that was a flat out guess.
I thought that was the circumcision. When you do perpendicular
Nope, you were
lines.
wrong. I was right in math.
Wait, what did I ask about?
You said
Oh.
Oh, I didn't mean orthocenter. I meant circumcenter. He knew what I meant. He knew what I meant. That's what I meant. I meant circumcenter. Hold on. We haven't gotten there yet.
Wait.
Yes,
It's like orthocenter.
we have learned. Orthocenter is altitudes. What altitudes make? Okay? We are.
Many orthodontists in one place.
I'm not the smartest person.
And wait, what does that mean? What do you make of that?
We're getting there. So in center, guys, listen. In center, equidistant from the side. Circumcenter, equidistant from the vertices. Okay, we just learned centroid, which splits it into 2 segments. One's half of the other. Okay, now we haven't learned anything special about the orthocenter. We learned that it's constructed from altitudes. We did learn that, but we didn't learn that there was anything special about it. Okay, so the special things about the orthocenter. Okay, 3 things to know for sure. Okay, in an acute triangle, it will be inside the triangle. In a right angle, it will be on the vertex of the right angle. So it will be right on the 90. That will be your orthocenter, okay? And then if it's an obtuse triangle, your orthocenter will be outside of the triangle. Acute inside, right on the 90, and obtuse outside.
Orthocenter is altitude.
Machine, can I try your glasses on?
No.
Say that again.
Acute inside, right on the vertex, on the 90, and obtuse outside.
How do you find it? Doing bisectors?
Altitudes.
Oh,
Guys,
I'm bad at that.
hey, you've got to know what makes what, okay? That's the whole all my children are bringing in peanut butter cookies thing. It will help you. Okay, here's stop. Another thing that makes OrthoCenter that's interesting about OrthoCenters is, so I've got triangle ABC right here. Everybody with me? See it? The OrthoCenter of ABC is inside and it's right here. Okay, now it's acute, so it's inside, right? Now, something I can say is that if I took this triangle, let's name OrthoCenter. This is point O. Everybody with me? So if I made this triangle right here, if I made this triangle,
Both line A, O,
then
equal to line B.
if I made that triangle, then C is the OrthoCenter of that triangle.
What?
Okay, hey, that's something special about OrthoCenter, okay? If I created, there's 3 different triangles here, okay? There's a triangle here, and a triangle here. If I created a triangle from the OrthoCenter and 2 sides and 2 vertexes, then the other vertex of the original triangle is the OrthoCenter. It's kind of cool. No, it's a new OrthoCenter of a new triangle. Yeah, so if I took this triangle over here, what would the OrthoCenter be?
This one.
A. And if I took this triangle right here, what would the OrthoCenter be? B. So that's kind of cool with that. Yeah. What?
That is dope. Oh!
It's not. Nobody ever said it was the center of the triangle. Huh? These are altitude. Shh. Guys. Okay. This is an altitude. If I kept this going, that's the altitude. This is an altitude. This is an altitude.
I got it. I can't wait to watch this podcast.
So, I mean, I can do it. I could do it to prove it. I did it yesterday to prove it. It absolutely 100% works. Okay? So, forming your altitudes. So, this is an obtuse triangle, guys. So, because it's obtuse, hey, my OrthoCenter should be on the outside. That's what it tells me. Absolutely. All right? So, that's just something that's kind of cool about the OrthoCenter.
I know we went over this already, but just making sure finding the midpoint and perpendicular is the same way.
Midpoint and yes. All right. So, your homework for tonight. No. That's your homework for tonight. I'm gonna pass around what? No, actually, I'm gonna be passing your quizzes back now. Write this down.
Your class to me is like a big fat brick on my head. So,
You know that's our recording.
no, I'm saying because it's hard.
That's on the podcast.
It's good to be out of your comfort zone. Did you pay attention to Java?
Yeah, but like something like
you were
something I
on your
just
phone
don't
the whole
want to do.
time.
This class, it's like it's not my comfort zone.
why don't you
So this class pops my bubble, and I'm not in a comfort zone.
Wait, do we have a test on Friday? Wait, do we have a quiz on Friday?
All right. Listen up. I'm passing your quizzes back. Stop.
Oh, I mean,
This is how this is gonna go. I'm passing your quizzes back. Look over them. We're gonna totally go over the quiz, okay? And then I'm gonna recollect them. So you can write on your quiz. You can make corrections on your quiz, and then you can take a picture if you want. But I'm collecting them back,
When's our unit?
okay?
can I make corrections?
What?
And get them regraded?
Can I change your grade?
Yeah. When's